Hello and welcome to Congruence and Rigid Motion. Please make sure you have your page 41 in front of you. We are going to discuss example 2. Basically, it's talking about if we took this first triangle and we in fact rotated it 240 degrees about point P. Now this looks a little confusing because when I first looked at this, I was thinking that the triangle was rotating this way, and that would be approximately 120 degrees, but actually it's rotating this way 240 degrees almost all the way around to this point here. So remember, when it says 240 degrees, we're talking about going in the counterclockwise direction. Either way, I do want to point out that angle A goes with angle X. That's the corresponding angle. Angle B would go with angle Y, and angle C would go, in fact, with angle Z. So again, if I was to rotate this 240 degrees, it would wind up here, and if I was to rotate this 240 degrees, it would wind up there. The same thing could be said for the sides, so keep in mind that if I was to rotate my sides 240 degrees, let's say I took side AB, when I rotate it, it winds up that it would be at side XY. So think about it, those two kind of would match up. And if I was to look at side AC, which is in fact the one on the bottom, and it would wind up at side XZ here, again 240 degrees, so that would be XZ. And the last piece, if I did it in blue, side BC, rotated 240 degrees, would wind up at, in fact, YZ. So there is definitely a correspondence between these two triangles. And the next question says, are the triangles congruent? And the correct answer would, in fact, be yes. They are congruent because rotations are, in fact, rigid motions. So please copy that down. And then it asks specifically what rigid motion maps one onto the other. So you have two choices here. A rotation of 240 degrees about point P, or you could do a rotation of negative 120 degrees about point P as well. So either one of those would be correct. What I want you to do now is take careful attention, or pay careful attention to the order of the letters that are happening in this triangle right here. It says triangle ABC. Notice the order. A comes first, B comes second, and C comes third. When it goes to the second triangle, X comes first, Y comes second, and Z comes first. And there is a direct relationship between A with X, which is in fact the first letter and the first letter. There's a direct relationship or correspondence with B and Y. Notice those are the middle letters of my congruent triangles, and the last one, C with Z, the last letters of my triangle. Now, ironically, this happens also with the side lengths. So AB over here is the first two letters, and XY is the first two letters in your second triangle. AC is the first and third letter, XZ is the first and third letter, and the last one, BC, is the second and third letter, and YZ is in fact the second and third letter there. So the order in which you write these triangles really matters, and please make sure that you try and pay careful attention to that. Let's take a look at the next page, please. So on this next page, it's talking about the fact that we are going to take a square, ABCD, and we have a diagonal, which is AC, and we're going to, in fact, look at this triangle up here, which is triangle ABC, and we are going to reflect it over the diagonal AC, and it's going to wind up over here. So a couple of things that are happening. First of all, the corresponding angles. Angle BAC, in fact, goes with angle DAC. Angle DAC. Angle ABC goes with angle ADC, and angle BCA goes with angle DCA. So there are also corresponding sides that are related. So AB is corresponding with AD, BC is corresponding with DC, and AC is actually corresponding with itself. So AC, when you have a reflection over the actual line, nothing really happens. Now it talks about, are the corresponding sides and angles congruent? Justify your response. This is a rather lengthy discussion or justification, but please make sure you write it down. Yes, in a square, all sides are congruent, all angles are right angles, and the diagonals bisect the angles. So that would be perfect. Are the triangles congruent? And you could think to yourself, well, is it a rigid motion? And yes, a line reflection is in fact a rigid motion. So please make sure that's copied down. And then when you're ready, we'll go to the next page. Actually, it's the bottom of that page, but we're on number 2 now. It's talking about triangle XYZ, the bigger one, is twice the length of the smaller triangle. So one of the things that we could look at here is BC times 2 is equal to YZ. So this little piece here, if I times it by 2, I would get that big piece there. The same thing could be said about the next piece. So we'll go with AB and XY. So AB times 2 is equal to XY. And then the last piece, we're going to go AC times 2 is equal to XZ. Now this is an interesting thing. It asks, are the triangles congruent? And immediately you should realize that we probably did some form of a dilation on this triangle. And no, all the sides are not congruent. And a dilation is not a rigid motion. Therefore, the triangles are not congruent. This leads us to probably the most important discovery in this case, which is the fact that if we have corresponding parts, do not always result in congruent figures. So if you have a dilation, they are not congruent figures. If you have a line reflection, a point rotation, or even a translation, those would in fact be congruent figures. All right, thanks, and I'll see you later.